Okay, problem 9. Fx is absolute value x times x. So first, is f differentiable? So is fx differentiable at 0? So fx is differentiable at x equals 0. It is equivalent to say that by definition, right? By definition, fx derivative, it's the limit when x is approaching, when h is approaching 0, fx plus h minus fx over h exists, right? So f prime 0, it's limit h is approaching 0, f0 plus h minus f0 over h, right, exists. So it is limit h is approaching 0, fh minus f0 over h. Okay, so it's limit. What is fh? Just by definition, it's h times absolute value of h minus 0. Right, minus 0, 0 times absolute value of 0. Divide by h. So limit h is approaching 0, absolute value of h, right, which is 0. Okay, so by definition, this limit exists. So f prime exists. Okay, and f prime 0 is 0. Okay. Problem 10. Fx is e to the power of x over 2 plus x if x is greater or equal to 0. Cosine 1 minus e to the power of pi x if x is smaller than 0. Okay, so is fx differentiable? So differentiable, I just use df, right? Differentiable at point 0. Okay, so we have this corollary to use. If fx is differentiable at point A, then fx is continuous at this point. Okay, now it's contrapositive. If fx is not continuous at the point A, then fx is not differentiable at point A. Okay, so we want to prove, so we see this function, let's see first if it's continuous at point 0, right? Is this continuous at point 0? So if it's continuous at point 0, the limit from left, okay, the limit from left is cosine 1 minus e to the power of pi x, right? Its limit, now we can just sub in. Okay, when you sub in, it's cosine 1 minus e to the power of pi times 0. So e to the power of 0 is 1, so its cosine 0 is 1. What about the limit from right? It's e to the power of x over 2 plus x. So you can also sub in it's e to the power of 0 over 2 plus 0. It's half. Okay, you can see the left does not equal to the right. Which means the function is not even continuous, right? So first, this means that the limit does not exist, right? This limit does not exist. This limit does not exist means the function is not continuous. It's not continuous at the point 0. Okay, so is f differentiable at x equals 0? Fx is not even continuous at this point, so fx is not differentiable at this point. Okay, this is the easiest way to solve this problem.